Welcome to Fast Click Massive Tutorial. This video will cover the filter section and I will be providing you with basic knowledge and examples if necessary. Massive consists of two separate filter buses where audio signals can be routed through serial or parallel settings. Either way, it gets routed to one of the two main filters of this plugin. These are very significant in sculpting the sounds, giving them its own distinctive sound. This setting is when filter 1 receives all signals that are sent to filter 1 using the oscillator's routing faders. This also applies to filter 2 in the same way. This is the default setting on the plugin. This setting routes the signal from the output of filter 1 to the input of filter 2, which means the signal gets filtered twice. This is set by bringing the fader to the very top. This fader controls the main filter output of the filter signal. Here are the settings to get full results from both parallel and serial routing. First, make sure that the filter 2 fader is turned all the way up because on the default it is turned down. Bring the oscillator faders to filter 1. In this case, I've chosen Lowpass filter and a Highpass filter. Turning the mix to the middle will give the full parallel effect. As said previously, serial setting routes from filter 1 to filter 2. Therefore, setting the oscillator routing faders to filter 2 will give no effect. Turning the mixer to mixer 2 will give the full result. You will hear the filter 1 and filter 2 at this point of the fader. A cutoff frequency is a characteristic of filtering devices. The audio signals of these devices will reduce in amplitude depending on the type of filter, and at this point, the cutoff frequency is the point at which the filter takes effect. Bandwidth is the width of the frequency spread. Let's move on to Massive's filter types. Most filters consist of a cutoff control, a resonance control. Some have additional bandwidth controls. The first 4 filters introduced can be modulated using the filter frequency modulation through the modulation oscillator. This filter damps all frequencies above the cutoff frequency by the rate of 12 decibels for Low-Pass Filter 2 and 24 decibels for Low-Pass Filter 4 per octave. In simple terms, these filters remove high-frequency content. Before going any further, I will show you a very basic graph to explain the meanings of the damp rate of frequencies by 12 decibels per octave. This shows that the slope is attenuating in the rate of 12 decibels per octave. However, I did not write any example frequencies, but I hope this makes things easier to understand. This filter works the opposite way as the low-pass filter by removing lower frequency content. This filter passes through all frequencies, however, the phase of the signal is inverted. This filter cuts 2 frequencies off. It suppresses a specific frequency range to very low levels, and most frequencies that pass are unaltered. This is the complete opposite of the bandpass filter. You can use this filter to stimulate phase-like sounds. Daft is another type of low-pass filter with its own particular sound. It is very responsive to the filter frequency modulation. These filters damp frequencies at a rate of 12 decibels per octave and has an adjustable bandwidth. These filters kill a narrow band of frequencies around the cutoff and passes most of the signal through. These are good for modifying specific regions of the frequency spectrum. At this point, including these filters, the next few filters cannot be modified through the filter frequency modulation. This filter is a type of low-pass filter with added internal feedback. The screen control controls the amount of the added feedback. This type of filter creates dirty sounds. This is a type of signal processing, where a delayed signal is added to the main signal to create constructive and deconstructive interference. When two identical signals that are in phase are played, it actually doubles in amplitude. This is constructive interference. The same situation with signals out of phase, it cancels each other out, resulting with no sound. This is deconstructive interference. This is a comb filter with an internal low-pass damping of feedback path. This consists of a feedback control and a damping control. Feedback can be turned off if the control is turned all the way to the left. This filter can have similar flanging effects when modifying the cutoff and feedback to the right settings. This ends my tutorial. Thank you for watching and make sure to subscribe to my channel.